Let's pick up where we left last time. We had the function f of x equal x squared minus 3x minus 4, and we wanted to find its domain. Well, remember the domain rules. We cannot have 0 in the denominator, and we cannot have a negative term inside the square root sign, or an even-powered root. But if you look, we have neither case here. So our domain, or the values of x that make this function true, are all real numbers. So remember to write that. We use a big boldface capital R. So that would be all the x's that make this function work or make it true. All right, let's look at another way how to find the domain and range, and we're going to look at the graphs of functions to determine that. So what you do is you pretend that the graph is a piece of wire. Now, you don't want it to be a rubber band because you don't want it to be stretched out, but you just pretend it's a piece of wire like a pipe cleaner. Then you lay it flat on the x-axis, since the domain is all the x values. The domain is the part of the x-axis that's covered, or parts, so when we take this graph and take the ends of the graph, this is where the graph starts. I know it goes to infinity, but we'll say this is where it starts, and this is where it ends. Again, that goes to infinity. But if we take the ends of the graph and lay it flat, pull these down, and pull this end down, we will get the graph to cover the whole x-axis. So this graph will cover the whole x-axis because when you lay it flat out, it's going to be a straight line. And if you lay it flat on the x-axis, it's going to cover the whole x-axis. So our domain is all real numbers here. So you could write capital R or in interval notation, we could write negative infinity to positive infinity. And that's another way we could write that. Now, to find the range, we pretend, again, the graph is a piece of wire. We straighten it, and lay it vertically on the y-axis, because the range are all the possible y values that make the function, that have a match with a domain element. So we try to find all the y values. So what we're going to do in this example is you don't exactly straighten it. Let's say we pretend that it's in an elevator door, and it gets smashed in the elevator door. So what's going to happen to this graph if that happens? If this end comes in and this end comes into the y-axis, and this is pushed in this way, and this side is pushed in this way, so essentially this side is coming in this way, and this side is coming in this way, and all the y values are going to be coming into the y-axis. So the range is going to be from this point up. from here up. Down here there's no graph, so there can't be any range values. So this value looks like 1. So the range is going to be from 1 to infinity in this example. So our range, we could say y is bigger than or equal to 1, or we can say, using interval notation, 1 to infinity. Means it goes on forever. So again, looking at the graph, our range is from 1 up. That's where our picture is. There's no picture below 1. So that's not in the range. All right, let's see if we can do that with this example. If you take this graph and lay it flat on the x-axis so that all these points are coming down, there's not going to be anything over here, and there's not going to be anything over here. So the only place that the graph is, if you flatten this graph to the x-axis, is from -4, or -5, sorry, 1, 2, 3, 4, 5, -5 to +5. So to write that, we can write -5 less than or equal to x less than or equal to 5, or in interval notation, -5 to 5. Now the range if we take the graph in this way to the y-axis, now all these y values are going in here. There won't be any values above 5, and there won't be any values below 0. So the range is between 0 and 5. Now remember, the range are the y values. Or you could write in interval notation, including 0, because 0 is the point on the graph, and 5 is the highest y value. So the range you can think of as the lowest y value to the highest y value. This is the range. The range is going to be from here to here. That's your range, because that's where the picture is. And your domain is going to be from here to there. That's what happens if you flatten out this graph to the x-axis. All right, let's look at another one. What's going to happen here? Well, for your domain, again, pretend you're sitting on the graph and flattening it to the x-axis. All these values will come down, and this part of the graph will be covered, and this part of the graph will be covered, but nothing in between here. Okay, so let's see how we can write that answer. Moving from left to right, we see that -infinity to -3 is going to be covered. Let's just write this in interval notation. So left to right is -infinity to -3, and we include -3 because there'll be a point here that's supposed to be connected. Now there's nothing between -3 and 3, and we use a union sign, or this means or, of 3 to infinity. So we have -infinity to -3, which is covered on the x-axis. This is our domain right here we're looking at. And then we have 3 to infinity. So again, it connects there, and it's 3 to infinity. Now the range if we look, is going to mean that we take the graph, all these values come over here to the y-axis, and you see, or you should see, that every y value is going to be taken care of. So we're going to be able to take this graph and everything is going to be taken care of. So the range is going to be all real numbers. It's not skipping over any values. So we have all real numbers for our range. It's going to be from negative infinity to infinity. Everything on the y-axis is going to get covered. Okay, let's look at this example, our last case. Now what's going to happen if I take the ends of the graph right here and pull them out? Don't stretch it, but just pull them out like it was a wire. And if you pull this end over and pull this end up and lay it flat on the x-axis, you should see that what we're going to get is the whole x-axis. This is going to come down, all this is going to come up, this is going to come up, this is going to come up, this will come up, and this will come down. So the whole x-axis is going to be covered. So our domain is going to be from negative infinity, or you could write just capital R, boldface R, negative infinity to infinity, because the whole x-axis is going to get covered. Now the range is a different story. For the range, we look at the lowest y value to the highest y value. So here, there's no picture, see, below here, and this value looks like it's -5. So this is right at about -5, so our range is going to be from here up, because all these values are going to come over here. All the y values are going to move over here, and this is going to be moved over here. Remember, all these values, you pretend it's squished in an elevator door, and from here on up is going to get covered. Nothing below -5 is going to be covered. So our range in interval notation, and we will include -5 because there is a point there. So -5 is the lowest y value. In infinity, it goes off to infinity. There's no high value because this keeps going on forever. So, hope this helps you how to find a domain and range just by looking at the graph.